Now that we remember a little bit about functions and inverse functions, I want to take a look at the sine function we have here. If we just do a straight swap of our x and y values, recall that the sine function will be reflected and it will become a vertical wave like this. And as we can see right now, this is not a function. This is a relation. It shows a relationship between x and y, but it's not a function because a vertical line crosses it in multiple points. We talk about a function being well defined. That means if I have a true function and I ask you what happens when this happens, you can only give me one answer. For example, if you ask me what my birthday is, I have one answer. There's one date. So the birthday is a function. However, if you ask me my child's birthday, I've got 3 kids. I don't know which one you're talking about. I throw my hands up. I say, I don't know. Which one are you talking about? That's when a function is, or that's when a relation is not well defined. In this case, I've got this green line at 1/2. So I'm saying, when is sine x equal to 1/2? Well, I don't know if you mean when it, well, I don't know if you're talking about pi over 3 at 2 pi over 3 at 7 pi over 3. Sine is 1/2 quite a number of times. So we're going to have to do a little trick called restricting the domain. Let's go back to our original sine function. And in order to get this to be or to have an inverse, we're going to restrict the domain. We're going to look at all of our y values happening exactly once. The way to do that is to chop this sine function at negative pi over 2 and at pi over 2. And what that gives us is a segment of the sine function that has an inverse, that we can take an inverse function of. And let me look at what that is. That's this part. This is the part of our sine function that we can use to come up with an inverse sine function. And when we flip this, when we let our x's become y's and our y's become x's, we end up with that function. So this is our inverse sine function. It has all of my y values from the original sine function have become all of the x values in the inverse sine function. So whereas the original function went from -1 to 1 for my y values and negative pi over 2 to pi over 2 for my x values, my new function, my inverse sine function, is going to go from -1 to 1 for my x values and from negative pi over 2 to pi over 2 for my y values. So let's figure out how we're going to use the inverse sine function. If I ask you what is inverse sine of 1/2, what I'm asking you is for what value, sine of what, or as we're more appropriate, we would say sine of what variable, what value, equals 1/2. So that's what we're asking. That's the relationship here. We know that sine of pi over 3 and 2 pi over 3 and again 7 pi over 3, so on, all of these angles will give us a sine of 1/2. However, we need to know one specific answer. So what we're going to do is look at between negative pi over 2 and pi over 2, and if we look at the unit circle, that means we're looking at this side of the unit circle, and we look for where our y value on the unit circle is 1/2, pi over 3. So inverse sine of 1/2 is going to be pi over 3. Another way you'll see this written, the inverse sine, and you'll see this a lot in the homework, is arc sine. Oftentimes it is not on your calculator as arc sine. The calculators that I've seen all have this inverse function notation, but just know that those two work together. They are identical in what they do. Let's see, let's try another one. How about inverse sine or arc sine of negative square root of 2 over 2? So we're asking ourselves, for what value do we get negative square root of 2 over 2 when we take sine of it? And looking back at our unit circle, our y value is negative square root of 2 over 2 at negative pi over 4.